Good morning. This video is going to be a short little video about the vertical milling machine, or we commonly just call it the mill. It's vertical because the spindle goes up and down vertically. There are some machines that go horizontally, but we have none in our shop. So mill is what this is. So I want to talk about some of the different features. There's a lot of features. We can move the head around. We can do all kinds of stuff. We've seen some of that in the textbook that we've looked at, but as a basic entry, get started, let's get going type of informational little video here, I want to just show you some of the basic things, some of the main features, okay? So anytime we put a cutter in and we want to cut, whether we're drilling, we're using an end mill, whatever we're doing, we need to calculate the RPMs, okay? The RPMs, we use that speed formula, speeds, so we have to apply our cutting speed times 3.82 divided by the tool diameter. Once we figure that out, let's say we did the math, boom, 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 and it comes out to be 1500 RPM. I have to be able to set it on the machine here somewhere with these various levers and turn it on to get it to work, okay? So, the way that we have this is up here, I have a high speed and a low speed. And we have a high gear and a low gear. And then we turn the spindle on. And whether we go forward direction or reverse depends on if we're in high or if we're in low gear. So let me zoom in here a little bit, see if I can give you a closer look at the top where these knobs are that I'm talking about. And I think that should work. So 1500 RPM, I'm going to look up here at this chart. Now in order to do these change in the RPMs, I have to look on the side and see what gear I'm in. So let me move it around so that you can see the side. Thought I was a little smoother than that. But this lever right here, I push it in and I rotate it around. But when I do that, I have to turn the spindle by hand to get it to drop into gear. So let me zoom back out a little bit so we can hopefully see both. There we go, that should work like that. So, in the middle is neutral, it locks in and then it spins freely. If I push it in and rotate it to the back, you'll actually hear it drop into gear. If I spin it too fast, it grinds the gear. So nice and easy, it drops into gear. In the back is low. There's not a lot of times we use low. The bigger the cutter, the slower the RPM. So it would depend on the size of the cutter. But if I'm using a smaller cutter, I want it to be in high gear, turning the spindle. Again, same thing. If I turn it too fast, I can hear the gears. But I want to feel it click into gear, and now there's some resistance, so I know for sure I'm in gear. If I'm not completely in gear, it's going to grind the gears, okay? And everyone's going to hear it, everyone's going to run over and see what you did, okay? So, we're in high gear, and so now I want to set our RPM. So let me move this camera back out. To about like this. All right. So that has to be done, obviously, if I'm worried about the gears, grinding gears and all that. The machine is off when you're changing high and low gear. Think of it as a transmission on a car. Manual shifting, if I don't have a clutch, which there isn't one, you're going to grind the gears. So, It's in high gear, which is what I want in order to get to 1500, because high speed goes from about 500 to a few thousand, and low gear is like 100 to 500, okay? So, in order to change this dial, there's a whole little configuration connected up to this knob. So this knob, I turn and it makes this dial turn for a visual, but it's really moving a pulley so that it's because it's a variable speed head. So it's changing it up inside, we're just getting a visual on the dial. If you crank this when it's not spinning, it messes it up. And then 1500 RPM is no longer 1500 RPM. So that's a no-no, okay? So no spin, no machine on, and then this we want it on. So there's two directions, forward for high and reverse for low. I've marked on here high and low to help make it a little bit easier. So I'm going to turn it to high. And my machine must not have power because we've been out. There we go, reset it. All right, so turn the power on. I ought to show you. Anyways, we at South Elgin High School have our disconnect box on the wall. If I turn the power off and I turn it back on, this is a safety so that, let's say we're running in the shop and my spindle's on and boom, we have a lightning strike and a power out. Even if it's just brief and it comes back on, that spindle would come back on under normal conditions, the way the machine was wired. So they've added this box so that if the power goes off and the power comes back on, I have to press this button to reset it so it'll come on. So that's what I actually did. The power was on. I had to reset it because there must have been some power issue. Okay, so let me get us back up here. All right, so I'm going to turn it on. It should go on now. Yep, there it is. And then I just crank this dial. As it's going lower here, the spindle's going lower. You probably hear it. And if I go higher, it's a little quieter. There is a red zone up here. It's about 3,000 RPM. That's when you kind of get into the limits of the range, like maximum speed. So we try to stay out of the red, just like in a car, you don't red line it. So I'm going to dial this back down to 1,500 RPM, which is in between 1,600 and 1,400, so I'm good with my RPMs. Up here, this is the brake to make it stop. Okay? So that is how I would set my RPMs and get that set up. Okay? Ready to go. Okay? So some other handles up here that we need to work with or want to work with are about how to make the spindle go up and down. If I'm going to drill a hole, let's say. Let me come back out a little bit so you can see. So we know that this is called the spindle in here, and when I move this, I'll make sure I'm out of the way. Okay. When I move this down like a drill press, many of you have seen a drill press, this is the quill that comes out. They call it the quill. This is a scale on the quill, and this is called the Quill Stop. It can be set anywhere you want. So let's say I only want to drill this deep. I set the stop. I can also lock the quill with a quill lock. And you don't have to force the tar out of it. It just needs to be pressed down so that it holds it in place. The last thing you want to do is release this, because there's a spring in here that makes this return automatically. And I've done this, and it hits right here, and it hurts a lot. Oh, right here, and it hurts a lot. Okay, when you let go of this, this thing spins around, and this ball hits me right here, and it hurts a lot. So you don't want to do that. So if I'm going to release it, I put my hand on here, and I release this, and then I kind of walk it up. You don't want to fly it up anyways, because you can end up breaking the spring that's in there. So sometimes this lock doesn't lock, okay? So there's a little trick here. And the trick is, there's a little black disc back here, and if I pull out on the silver part and hold a little black disc, I can rotate the silver thing, and it goes back in and re-engages, and then I can change it. So now, look, it looks like it's locked, but it doesn't lock, okay? And sometimes students will loosen it up so it doesn't work because they don't want it to be in the way, because sometimes it naturally locks and then it's hard to move this. If it's ever hard, this thing is locked. So hold the little black disc behind, pull out, rotate this till it's free, and so now it won't lock at all. Okay? So I got to find the happy medium. I try to set it to where it locks a little bit of pressure right down at the bottom, because that way the weight of this, if I were to do it here, the weight of it would put resistance on it, and then it would be harder to move this, and that's inconvenient, plus it's adding extra wear, which we don't really need. Okay, so again, I try to make it so that it locks down low. It also keeps students from not cranking the tar out of it. So that's the lock to make this go down. And it's a little bit too tight, so let me loosen it up. There we go. Okay, so I said this is the quill. This is the Quill Stop. Okay, so if I'm milling and I want to come down a certain distance and I want to be able to retract or move this back up out of the way, I like to keep this about halfway most of the time. So I can bring this down and lock it, but then it'll allow me to get out of the way and come back. So that Quill Stop is so I can repeat coming back to the same spot multiple times, because sometimes you need to do that, all right? And if it's way down at the bottom and you crank this quill all the way out, the farther this quill comes out, if it comes out another 4 inches, then this becomes a little bit less stable, okay? It wants to flex and move, okay? So halfway is a good distance, okay? So some may say, well, how do I control the other depth? Well, let me zoom us back out a little bit. If you remember from the textbook and our conversations, we have handles. Oh, I got to come back a little bit more. Come down a little bit more, because we got to see what they call the knee. If you remember, we have a table, a saddle, and a knee. The knee is down here, this big heavy-duty mass. There's a big screw here, and this handle right here cranks this up. This is very accurate, just like my Y saddle is very accurate, and my table X is very accurate. This up here is just a ruler. It is not that accurate. So I can come down here to my Quill Stop, lock it. Now, if my cutter's sticking out, I can raise this knee up accurately because it has the numbers on the dial. So I can raise it up to get exactly to the spot that I want. And I'll demonstrate this in further, but I wanted to hit these main introductory things about the handles that we're going to use. We're going to use Y-axis to move in and out. We're going to use X to move left and right. And we're going to use the quill and the knee. And then remember, this is the brake. If you have a knob that's kind of loose, someplace, tighten it up before it falls out or strips out. Okay, so there's two knobs here, switches. Okay, I only talked about this one. This is my spindle. If I go the other way, it goes counterclockwise when I'm in high gear. So we want to look at the label and we want to make sure we're going high or low. This other one is for a coolant pump. Can't hardly hear it, it's groaning a little bit. We don't do coolant in the machine, so we just leave this off all the time. If I were to put coolant in the machines and use these nozzles for coolant, it would be such a splashy mess all over the place. You'd be taking a bath and it would be really, really, really messy. So, for the basics of the machines, that should get us going, other than the fact that we have this here. This is called a digital readout. Digital readout. So we have two ways to be accurate. There's little lines and numbers on these discs on the end, so I can be accurate. Or I can first plug it in. We haven't been in the shop yet, so power was off. Press clear to recall position. Move the handles. So this digital readout goes to the 4th decimal place. I can set my 0, press X once, press X twice, now it's set. There's a choice between ABS, that's absolute, not anti-lock brake system, and INC, which will be incremental. We always want it to be incremental. Let me see if I can zoom in a little bit. I guess that works. See, it's INCR, incremental. We don't want to play with that. I always say go to absolute, and there's an absolute incremental button up here. And then when I move, I can set my 0 once, twice for both my axes. So we'll get into setting 0, how we set 0, because my dimensions on my print come from a certain size from a certain edge on the part, and we got to stay within that in order to hold our tolerances. So that should take care of it. High-low gear, spindle off. RPM, based on high or low, spindle on off. Quill lock, Quill stop. All right, have a good day.